Alright, so last week we learned about volume. Volume was about filling up an object and how much it could hold. Surface area is how much is on the outer sides of the surface. Like if I was to paint this an object, how much paint would be needed for the whole object to cover? So surface area can be expanded out into several different shapes. And it is the combined totals of all the areas of the shapes that it is formed. Before we get started, I have some corrections that need to be done on the pages. First off, you know SWAT has it all stapled Willy Wonka anyhow.
And 87.
Oh, why do they always do that?
So, look at rectangular prisms first. Anywhere you see red, you need to fix. So number 4 and number 6, fix those side links and the total surface area.
I can't read. That's 7.
Okay, now we're going to do corrections on triangular prism. It has a few more and they left off some side links. So this 2.82 is going to this side length of the triangle, which was necessary to have. Same thing here. So any red, you need to correct or add to your paper. Alright, so now we're going to practice. So make sure you're on rectangular prism for both packets, because we know the stapling ability is not up to par.
No, it's not. Stapling forward.
So, number 1, looking at the shape of number 1, what do you find unique about it?
It's perfect square.
It's a perfect
Cube.
cube. When all of the sides form a cube, squares, it forms a cube. So it is perfect cube. Well, cubes are delightful to find surface area for, because what shape is that?
Square.
A square. If I turn the shape like this, what shape do I have?
Square.
Is this square and this square the same size?
Yes.
Are all these squares that it forms the same size?
Yes.
So how many squares total are there in a cube?
6.
And they're all the same size. So that makes life easy when finding surface area.
By the area.
So I'm going to find the area of one of the squares. But how many squares am I going to need?
6.
6 of them. So I'm going to put that right there so I don't forget. What is the formula for area of a square?
Length times width.
Length times width. Well, what is my length? 5 times what is my width?
5.
And my area of one square would be 25. But how many squares do I have that is that size? 6. So I'm going to multiply that times 6. And I get 150 yards squared. And I can highlight that and be done with it. So that's how easy cubes are.
Why do you put square instead of
Area. Yes.
I thought it was 1.
Now, for number 3, I would suggest writing very tiny because it's a lot more work. On number 2. What did I say?
Number 3.
Number 2.
They're the same thing.
What shape? This forms a rectangular prism. Nothing unique about it. But here is an example of a rectangular prism. All right. Well, this face, what shape is it forming? A rectangle. This shape, what is it forming?
Rectangle.
Is that rectangle and this rectangle the same size rectangle?
No.
So people on my video, I said this rectangle right here is not the same size as the top side of the rectangle. So, does this front side, the front of my rectangle, have a matching side?
Yes. The back
Where?
side.
The back. So the front and the back is its only two matchers. Does the top have a matching side? The bottom. What shape does a side form? A rectangle. Does it have a matching side?
The opposite.
The opposite. Okay, so we have to keep that in mind when finding surface area of this guy. Remember I said write small. You're going to run out of room. So first shape, all of them formed a rectangle. So I'm going to say rectangle. What side of this figure do you want to look at? Top, bottom, side, side, front, back.
Top.
All right, so we're looking at the top and the bottom. And how many of these rectangles are going to be the same? Two. How do I find area of a rectangle? Length times width. So I'm looking at the top and bottom of this shape. So I'm looking at this little gray area here. What is its length of this gray area? 10. What would the width be?
3.
The 3 has nothing to do with the gray area. 8. 3 is the part standing up, going tall. So this is an 8. 10 times 8 would be 80. How many sets of 80 am I going to have? 2, because it's two sides, top and bottom. That gives me 160. That's the area just for the top and the bottom. I still have 4 other sides to find. So I'm finding another rectangle. Which rectangle you want to find?
Sides.
All right, sides can come next. And how many sides am I going to have? 2. So the sides is this end piece here, little triangle. So what's the length?
8.
Rectangle. Did I say triangle?
Yes.
Rectangle. So its length is 8. What is its width? 3. How'd you know 3? Because all these lines standing up is 3. 3 times 8 is 24. How many sets of 24 am I going to need? 2. So that gives me a 48 for those sides.
Wouldn't the 3 be the height of the
3 is the height, but it's forming this rectangle of the side. So you look at my shape here. Here is the 3 of the height. It's using that to find the side. So a 3 and an 8. This is the 10. Okay. I have another rectangle to find, and that is front and back. And that gives me 2 of those guys. So the front is looking at this rectangle. It always helps me to trace the shape I'm looking for to see the sides. So what is the length of that rectangle? 10 times what is the width? 3. And that gives me an area of 30. How many of those do I need? 2. Gives me 60 for those sides. Well, I have a lot of people that likes to stop here, and they did all that work for nothing. To find surface area, you've got to add them all together. So surface area is all of those, 160 plus 48 plus 60. When I add all of that, I get 268 inches squared. Now I finally gave the surface area, so I can highlight that off. Oh dear. Highlight that. and I found the surface area of that rectangular prism. So it's not hard, it's just
A lot of work.
a lot of tedious work.
It is fun.
Great deal of fun.
This is what I like it. It's not.
So that was rectangular prism. Next example I'm going to do is triangular prism. So make sure in both packets you're looking at that, because the packets are Willy Wonka.
Why do they do that?
I had them an exact example of what I wanted the packets to look like.
They're
Triangular prisms. All right, so here's an example of a triangular prism. What shapes are involved to form this figure? Triangle. How many triangles? Two. Are the triangles going to be the same size?
Yes.
Triangles are going to be the same size. What other shapes are involved? Rectangles. This shape kind of looks like all of them are the same size, but not always are they all the same size. For instance, on this number 1 example, look at its base. Its base dimensions is what?
8 to 14.
8 by 14. Well, look at this tall side here. It's 7.21 by what?
14.
Is that the same as the base?
No.
No. Well, what about this other side over here? What is its dimensions? 7.21 by 14. So, do I have 2 sets of bases? No, I just got one base, and it just so happens in this problem, I have 2 sides that are the same lengths. That doesn't always happen, but it sometimes happens. And I have 2 triangles. Are the triangles the same, we said? Yes. All right, so what shape do you want to find first? It really doesn't matter. All right, I hear triangle. How many is going to be this size of a triangle? 2. What is the formula, anyone remember, for area of a triangle?
1/2 times base times height.
1/2 base times height. So I have 1/2. What is my base of this triangle?
8.
8 times, what is my height of this triangle?
6 feet.
6. Okay, I want to pause there for a second. You're pausing your brain. Look at number 2. Look at the triangles formed on number 2. It is a little different than triangles here. What would the base of this triangle be? 2. It's attached to that right angle. The base is 2, and the height is 2.
It's hard to picture these.
Yeah. So when working this one, did they have a height drawn down the middle? No, because it formed a right triangle. So the height is the 2, the same as one of the legs. Just remember that. All right, unpause. Back to this problem. I don't know what I just did that for. What is 8 times 6? 48. What's half of 48? 24. How many sets of these areas do I need? 2. So times 2, and I'm back at 48. So my triangle's area is 48. Now what you want to find? Rectangle. What's rectangle?
The bottom one.
The base out here? Sure, the base. Formula for that is length times width. So I'm looking at the base. What is my length? 14 times the width, 8. I'm looking at the base. The width is 8. What's 14 times 8? 112 maybe?
Yeah.
112. How many of these rectangle sizes do I need?
One.
I forgot to put that there. I just need one of them. So I'm going to go ahead and circle that.
Miss Adams,
Yeah.
could you just multiply that by 3 in your grades, or no?
Could I? Are they the same size rectangles?
No.
No.
No, they. Oh, yeah.
Sometimes they could be, but in this case they are not. Good question. All right. Now I need to find another rectangle, and these are my sides ones. How many is going to be like this size?
2.
2 of them. So, what is my length of this size rectangle? 14. And the width of this one is 7.21. Then 14 times 7.21. Oh dear. 14 times 7.21. I get 100.94. How many of these do I need?
2.
So times 2. I get 201.88 is the area of the side rectangles.
What do you have to add?
So for surface area, I've got to add those up. 48 plus 112 plus 201.88 gives me 361.88 and feet squared.
It's 5.
All right, a refresher that your base is always going to be your longest side of the triangle. So this would be my base, 2 would be my height, and you will get an answer around this answer. It's probably going to be 31.9282, somewhere around there. As long as you have your work, I'm good. All right, moving on to pyramid. So turn to pyramid. I am working problem number 6. So make sure you're in the correct section. We've been finding total surface area, but there's something called lateral surface area. Lateral surface area is if I was to take this triangular pyramid or prism, and that was my shed, my building in the back of my house, and I wanted to paint it. Am I going to worry about painting that bottom that is sitting on the ground?
No.
No. I am going to paint all the other sides that is above the ground. So lateral surface area is all your sides excluding your base. So not including your base. Well, number 6 has an example of a pyramid. They just flattened out the shapes. If I was to fold those triangles up, it would form a pyramid. What do you think is the base of this pyramid? What shape?
The rectangle.
The rectangle. So if I'm finding lateral surface area, I would not have to worry about finding this rectangle.
Is that why they didn't give us any information? Or never mind, I did. Just joking.
All right, so I'm on number 6. I'm first going to do my work for the lateral. What shapes are going to be involved for this lateral surface area? Just triangles. Are all the triangles the same size?
No.
Oh, darn. Are any of the triangles the same size?
Yes.
Who does this match with?
The one.
The bottom, and this one matches to the other side.
Do we have to write small?
You do need to write a relatively small. Okay, so I'm going to find my triangle, and they're in sets of 2. So I'm going to look at the top and bottom triangle. You can label it top and bottom if you want. Formula for area of a triangle is 1/2 base times height. Well, what is my base of this first triangle I'm looking at? 6. What is its height? 4. What is 4 times 6?
24.
Half of 24 is, how many sets of these triangles do I need? 2. So the area of those 2 triangles is 24. So far, I painted that triangle, and I painted that triangle.
So how do you want us to show our work? When you're doing this, you could just do take off the half and just do the base times height? Or do you want us to show our work and do it? I like if there's 2 sides.
Okay, I need another triangle, and there's going to be another set of 2. What is the base of this triangle? 4. What is its height?
5.
What is 4 times 5?
Wait, yeah. 20.
20. Half of 20 is
10.
10. How many of those triangles do I have?
2.
2. And that gives me an area for those triangles to be 20.
On triangles, do we, if there's 2 of them, do we really have to multiply it by 2 or 0.5? If it's just
It's gonna help in the
algebra.
future.
Yes.
Is that right? It's gonna help in the future?
Because figuring out area involves a half. If you did not involve a half, it wouldn't make sense.
I have a question.
It wouldn't be mathematically correct.
So if you didn't, no. Because then it wouldn't be mathematically correct.
All right. So now I painted these 2 triangles. Is there any other sides involved in the lateral part? No, because this is what it's sitting on. So to find my lateral surface area, I'm just going to add 24 plus 20, and I get 44 feet squared is my lateral. So what is the only thing missing out of the total surface area?
The
The
bottom.
base.
The base, the bottom, which is a rectangle. So do I have to do all this work over again? No, I'm just going to find the rectangle, the base, and the base is, what is its length? 6 times 4, 24. How many sets of those do I have? 1, so that's done.
And add it to
Now, what do I do to get the total surface area? Add them all together, or I could take my lateral, add my base, would be a 4,
68.
and that gives me 68 feet squared is the whole total surface area.
This is fun to do.
I'm glad you enjoyed the geometry, Dave.
No, I'm actually really
It's funner than algebra.
It's funner than regular math.
All right, so this is due Friday. After Friday, will be thrown in the trash.
Yay!